Welcome to this remote edition of your lesson for today. So this is angle bisector theorem, and it's the very last lesson of the semester for geometry. So that's exciting, and happy Monday. So sorry I can't be with you today. Instead, you're going to be able to walk through this lesson remotely with this video, and it is a nice, easy way to end the semester. So before we actually get started in the new lesson, let's do a little warm-up. Take out your packet, and you know where to go. The very front page of your packet is where you do your warm-up. Look for the warm-up for December 9th, and you should find a place to put this information. And number one, we're going to look at a polynomial problem, okay? And the polynomial problem that you see here is asking which has the greater area. And remember that when you have the area of a rectangle, you're going to multiply your length times your width. And so in this case, you're going to multiply your length times your width. Well, these are polynomials, and so you're going to go ahead and make a box if you want to and multiply 3x plus 2 times x plus 3. Then you're going to do the same thing here, and then you're going to find out how much is greater, you're going to subtract. So take a second and do that. And then after that, you're going to look at number 2 and see if you can figure out how to find out what x is if you have x's in these two positions. Well, these congruence marks are telling you something, right? The congruence marks on both sides, they're telling you that ED is a mid-segment, and that's going to tell you what to do, or what the relationship is between x minus 3 and x plus 5. Take a second and do as much of this as you can. Pause the video and then come back to it. I definitely want you to remember how to do something like number 1. I definitely think this is something you might see on the final exam because it was something that was present on the interim, and this seems like something the count would throw on the exam. So give it a shot, pause the video, and then come back. All right, welcome back. You should have ended up for number 1 with actually 2x squared. Let's see, minus 6x, no, plus 6x, and then plus 2 as your answer here. And you would have had to find out what this was as a trinomial and also this as a trinomial, multiplying them together and then subtracting them. You should have ended up with 2x squared plus 6x plus 2. Now, remembering that a mid-segment is exactly half as long as that last side of the triangle that it does, or side of the triangle that it does not touch. See, the mid-segment touches this side and this side, but does not touch this side. So this is twice as long as this. This is half as long as this. So you could have taken 2 times x minus 3 and set that equal to x plus 5. That would have given you x is equal to 11 when you solved it. And then when you take that back and substitute that in to find the length of ED, you would have gotten 11 minus 3, which is going to be 8. Perfect. All right, moving on. Reminders that this week you can retest one test, either Unit 1A, 1B, or 2A. If you're going to do that, you must complete the Delta Math assignment to an 85% or greater. All right, you must. And then after you're done with that assignment, then you're coming to tutoring, either Tuesday or Thursday. Now, let's say, for instance, perhaps it's been so long that you've forgotten how to do some of this material and you need some help. Well, come for tutoring on Tuesday, get the help that you need. And then come to Thursdays as well, because Thursday, you really need to show me that you're ready to test, because otherwise I get a lot of garbage. Sorry about that, but it's true. Students think that they can come in and do better on a test without actually preparing, and you really have to prepare, and you guys can do it. I know you can do it. So let's knock this out and up those grades so that we end up this semester successfully. And then you're eligible to retest Wednesday or Friday after you've done your tutoring. You've done the Delta, you've done your tutoring assignment, and then you're ready to retest. And as always, you can replace unsatisfactory grades. Make sure you sign up for SST. And we only have 7 class periods, including today, until final exams. So today, the last thing of the semester is angle bisector theorem. Yay! All right, so like I said, this is kind of easy. So I hope that you find it easy as well. Let's look at what the angle bisector is for a second, and then we will go ahead and talk about how we use it. So the angle bisector theorem, sometimes it's also called the proportional side theorem. I usually have seen it only like this. And so let's use this, the angle bisector theorem. This says that if you've got a bisector of an angle in a triangle, it will divide the opposite side into 2 segments, and those side lengths are going to be in the same ratio as the lengths of the other sides of the triangle. Okay, let's talk a little bit more about that. An angle bisector is going to cut an angle into 2 congruent pieces. So in this drawing, segment PS is an angle bisector. It cuts angle QPR into 2 congruent angles, QPS and SPR. So while this is not the case in this, if angle QPR is 60 degrees, then angle QPS and angle SPR would both be 30 degrees. Okay, so that's what an angle bisector does. And if you've got an angle bisector within a triangle, then the segment pieces that it cuts the third side into will be in the same ratio as the other side lengths. So A divided by B will be the same ratio as X divided by Y. Okay. All right, so let's actually look at some examples that we can work out here. Notice that in number 2 on your notes, it did not have the angle bisector markings. It's got to have those markings in order to apply this. So I am asking you to adjust your diagram so it shows those markings, because you can't use this bisector theorem unless you actually have an angle bisector. In order to solve for missing sides in a triangle using this theorem, these are the steps. You're going to start by setting up a proportion. Okay. Next, you're going to cross multiply and solve for the missing piece, the variable. Okay. Next, you're going to double check and make sure that your answer makes sense. Now this says start with the unknown side in the top left of the proportion. I'm going to cross that out because I don't think that that's always going to apply. And I'll show you what I mean by that in a second. Okay, so let's look at these examples, but I'm going to show you what I've done here, because this is going to make it a little bit easier. I've taken example 1 and I've rotated it so that the angle bisector is a horizontal line. Now, if it's a horizontal line, then what I can do is, let's actually extend the line. This looks a little bit like our triangle proportionality theorem. Okay, we are going to first make this a variable. Okay, this horizontal line sets up the proportion. Here's the left side of the proportion, x over 18. And here's the right side of the proportion, equals 20 over 36. Okay, well that's not too bad at all. All right, so now you know what to do. You're going to cross multiply. X times 36 is equal to 18 times 20. So that is going to be 36x. And then what is 18 times 20? Hopefully you've got a calculator handy and you're going to say that that's 360. All right, and then you're going to divide out the x. You're going to get x is equal to 10. All right, and then you're done. Oh my gosh, piece of cake. All right, doing the same thing here. We're going to assign a variable. Now, I'm not going to assign this to be x since I already have an x in my diagram. Let's call this c. Okay, and I'm going to extend, like I did before, that horizontal line. Here's my equal sign. Here is the first piece, the left-hand side of my proportion. So I've got 20 over c is equal to 10 over 12. All right, okay. Now I've got my proportion set up. I'm going to multiply. Okay, so 20 times 12 is equal to 10 times c. So 10 times c is equal to 20 times 12, which is going to be 240. All right, and then I'm going to divide out that 10, and c will equal 24. All right, perfect. Perfect. Now, one thing that you're going to want to do after you've solved for your variable is you're going to go back and double check that it works, that it seems appropriate. Okay, so 36 and 20. 20 is a little more than half of 36, and then 10 is a little more than half of 18. That seems like an appropriate answer. Same here. If I'm looking at my answer of 24, 12 is a little bit more than 10, 24 is a little bit more than 20. That looks appropriate as well. Another thing to think about is when you're setting up proportions like this, and I've talked to you about this before, I think, sometimes you see a relationship here, like 36 times what gives me 18, or 36 divided by what gives me 18. If you notice that, it's going to apply here as well. So half of 36 is 18, so this must mean that half of 20 is 10, and that actually is exactly what we got. And if you're looking at this other one, 10 times 2 is 20. So that means that 12 times 2 is also going to be 24, which is the answer that we got. If you see that, you can use that instead of doing the cross multiplication thing because it's much faster. So here's a couple more examples. Let's go ahead and set them up. Let's see here. We're not going to rotate them this time. Here's my left side. So 25 divided by x is equal to, and then here's my right side, 15 divided by 6. Okay, cross multiply. So I have 25 times 6 is equal to 15 times x. So we'll say 15x is equal to, now if I had 6 quarters in my pocket, how much money would I have? Oh, hopefully you said $1.50, so 150. Then divide out the 15, leaving us with x is equal to 10. Let's double check, see if that appears to be appropriate here. A little more than twice, or 2.5 times 10 is 25. 2.5 times 6 is 15. That's great. Perfect. All right, and then let's look at number 4. Number 4 is a little bit trickier because I'm looking for the whole side length. Well, this angle bisector theorem that we're talking about here is not going to give us the whole length, but it is going to give us this part right here. But if I'm actually ending up wanting the whole length, what I'm going to want to do is take what I got there and add it to 12. That whole length will end up being 12 plus x. All right. So let's go ahead and set up our proportion. So x over 12 is going to end up equaling 21 over 28. All right, cross multiply. So we have 28x is equal to 12 times 21 So I think that's 252. Is that right? All right, and then we would go ahead and divide out the 28. I think that gives us x is equal to 9. All right, and remember that that gives us this piece here, 9. But we want this piece here, so 12 plus 9 is going to end up giving us 21. Okay, not too bad at all. All right, almost to the end here. Same idea, I think, for number 5, except that, look, we know that this whole piece is 12 and this piece is 4. And we've done things like this before where we say, oh, that must mean that this remaining piece must be 8. So here is our line creating our proportion, right? So here's our left side, 10 over x is equal to 8 over 4. Oh, well, that's easy, right? Because 4 times 2 is 8. What times 2 is 10? Well, x is equal to 5. Now, of course, you could have done that with cross multiplication. And you would have gotten 8x equals 40, and x would equal 5 there. All right. This is kind of like the one we did on the previous slide. Can you set it up? I'd like you to try it and pause the video and then double check. Okay, hopefully you set this up like this. 9 is over 6, and that is equal to 6 is over x. All right, and then we would cross multiply. 9x is equal to 6 times 6, so 9x is equal to 36. And that means x would equal 4. Okay, now if x equals 4 and we're really interested in the entire length, that's going to be 4 plus 6, and so this whole length would end up being 10. All right, last one. This one is a little bit spicy, okay, because we have an expression here, all right? Well, I think that you know that this piece is going to be 20, correct? And then we're going to go ahead and set up the proportion so that expression will be on the top. 2x plus 9 is going to be sitting on top of 20. And then on the right hand side, that's going to equal 20 over 16. All right, and so we're going to multiply, cross multiply, but do you see that this expression is being multiplied by 16? That means I need to distribute it. So use some parentheses here. 16 times 2x plus 9. And that's going to equal 20 times 20, and 20 times 20 is 400. All right, go ahead and distribute. 16 times 2x is going to give you 32x. 16 times 9 is going to be 144. And that's all equal to 400. We're going to solve this two-step equation by subtracting 144. And we would get 32x is equal to, I think, 256. And then when you divide out the 32, you're going to end up with x is equal to 8. All right. So if done there, we get x is equal to 8. Now, what if it asked us to find that side length? Well, then you'd go ahead and substitute that in and get 2 times 8 plus 9, 16 plus 9 is going to give us 25. And we'd be done. Excellent, excellent. Okay. All right, so what you're going to do for the remaining time is you're going to complete the 10 problem worksheet and turn it into the substitute before you leave. It needs to be turned in before you leave. Not going to be taken late. Okay. And then I will see you tomorrow. Hope you have a really good rest of your Monday. All right, take care. Bye-bye.